Hi everyone. In this section, we will introduce the calculation related with the line balancing, and of course, we will demonstrate how to assign tasks into different workstations through example. So this is example. We have the following information. This is what we call the precedence relationship table. It tells us we have total 8 tasks, A through H, and each of them had its own processing time. And the task takes the longest time to finish is C, which has a processing time 1.5 minutes, and task A has a minimum processing time of 0.1. And the last column tells us what is the corresponding immediate predecessor. Now, the first question is, what is the minimum and the maximum cycle time? If you remember, minimum cycle time actually is determined by the task that has the longest task time. Because if we only assign one workstation to work on any single task, then that will be the minimum time the workstation need to finish the assigned task. While the maximum cycle time is the sum of all the tasks time. Because if we have the worst case, we have only a single workstation which has to finish all the tasks, then that will be the time it takes to produce or finish the assigned job. So we have the longest task time is 1.5 minutes. So this is the minimum cycle time, 1.5 minutes. And the maximum cycle time, as we mentioned, is the sum of all these task time. So we add them up and get the maximum cycle time equals to 4.4 minutes. Next, now assuming an 8-hour working day, what is the cycle time needed to generate an output rate of 240 units per day? Now, here we have the information of the length of working day, which is available working time, and we have the required output rate is 240 units, and we need to calculate what we call is the required cycle time. Now the relationship between cycle time, operating time, and the output rate is the cycle time equals to the operating time per day divided by the desired output rate. Now we have the operating time per day is 8 hours, which equals to 480 minutes. And the desired output rate is 400 units per day. So we can calculate the cycle time as 480 divided by 240, which is 2 minutes, which means the cycle time of the process cannot be longer than 2 minutes to generate the 240 units output. Now we need to determine the minimum number of workstations needed. Now, minimum number of workstations is defined as the sum of all task time divided by the cycle time. Now, the sum of all task time is what we calculated earlier. We add up the processing time of each task and get a number of 4.4 minutes, which is the total processing time. And the cycle time is the one that we calculated in previous question, which is 2 minutes. So given these two numbers, we can calculate the minimum number of workstation needed is 4.4 divided by 2, which gives us 2.2. However, we cannot have 2.2 workstations, so we need to round it up to 3. So 3 will be the minimum number of workstations needed. Now we need to draw the corresponding precedence diagram. Now what we have the precedence relationship table, and we always start from the tasks who have no immediate predecessor, because these are the tasks that is not depending on other tasks. You can start working on these tasks immediately. So we start with these two tasks A and C. Both of them have no immediate predecessor. We start with these two. Next, task B. Task B has A as its immediate predecessor. So we draw B, and we need to have the error connection connect from A to B. This means that we need to finish A first, and then we can work on B. Next one, task D has C as its immediate predecessor. So we draw C, D, and connect them with the error. The next we can get E, which follows B. F is a little bit unique because F has two immediate predecessors, which means the two immediate predecessors D and E both need to be finished before we can start working on task F. So we have F, but F has two error connections pointed to F from D and E. So similarly, we can work on the last two tasks, G and H, and we can construct such a predecessor diagram. And of course, we need to put on the task time to finish it. Now we are required to assign tasks to workstation using this rule. So assign tasks according to greatest number of following tasks. In case of tie, using the tiebreaker of assigning the task with the longest processing time first. So we construct the table. This table has multiple columns, generally 7 columns. We'll explain them one by one. So column 1 is the number of workstation. We start with the first workstation. Time remaining is, well, what is the remaining available time for this workstation? The start working time is the cycle time, because all jobs assigned to each workstation need to be finished within the required cycle time. As we calculated earlier, for this problem, the required cycle time is 2 minutes. So every single workstation will start with 2 minutes available time. The next, eligible. Eligible basically means for the given system, what are the tasks that we can start working on? Now at the beginning, as we can see from the chart, A, B, C, D, E, F, G, H. Everything else cannot be started except A and C, because all other tasks depend on the finishedness of other tasks. So at the beginning, eligible one, which are the tasks we can work on at this time, are A and C. So we have eligible tasks A and C. Will fit means we compare these eligible tasks and see whether or not their working time is less than the remaining time. So the remaining time is long enough to work on the given tasks. Now we have A and C. A's working time or task time is 0.1 minutes, and C's working time is 1.5 minutes. Both of these two tasks have a working time or processing time that is shorter than the remaining time, 2 minutes. So both of them will fit in current workstation. Now we have two to select from. Which one should we use first? Should we work on first, A or C? Now here is the time we need to look at the rule. For us, assign tasks according to greatest number of following tasks, which means we take a look at these two tasks, A and C, and see which one has more following tasks. Then we assign this task first. Now we look at A. A has 1, 2, 3, 4, 5. A has 5 following tasks. C has 1, 2, 3, 4. 4 following tasks. Now, A has more following tasks, so we will assign A first, not C. So we assign A, which will use 0.1 minutes to finish. So the remaining time will be after we finish the assigned task. What will be the time remained in current workstation? Now, since we have 1.9 minutes available, we can try to assign more tasks to workstation 1. So next step, we'll start with 1.9 minutes, which are the remaining time. Now, since A is already done, we can start working on B now. So the eligible tasks are B and C. Well, both of them will fit because B's processing time is 1 minute, C's processing time is 1.5 minutes, and both of these two times is shorter than the remaining time of 1.9 minutes. So both of them will fit. Now again, we need to take a look at the rule and see which one should we assign first, B or C. The assigning rule is greatest number of following tasks. However, both B and C have 1, 2, 3, 4. 1, 2, 3, 4. 4 following tasks. Which means the primary rule, actually, we follow that and get a time. That is the time we need to take a look at the tiebreaker rule. So the tiebreaker rule of assigning tasks will be the longest processing time first. Well, usually we assign the job that has the longest processing time. The processing time, well, C and B, C's processing time is 1.5 minutes, B's processing time is 1 minute, so we assign C first. Sometimes we take a look at the processing time, but that is the processing time from the current task until the end of the process. But either way, C will have the longest processing time. So we assign C first. Now, we start with 1.9 minutes before we assign any task to workstation 1. Now, 1.5 minutes will be used. So the remaining time will only be 0.4 minutes. And since the remaining time is not 0 yet, so we'll keep on working on to assign job to workstation 1. However, when we start with 0.4 minutes, the two eligible processes B and D both have a processing time that is longer than 0.4 minutes, which is available time. So none of them will fit. Well, some of you may think, oh, I see, there are some other tasks, like task E only takes 0.2 minutes, task G only takes 0.3 minutes. Why can't we just work on these tasks first so we can avoid wasting time here? The problem is all the other tasks are not eligible at this time, which means we cannot working on these tasks yet, since they are depending on the finish of other tasks. For example, E. Before we finish B, we cannot work on E. This is the sequence we need to follow. It may be the design of the product or the design of the processing steps. So anyway, both of the eligible tasks cannot be fit into the available time, so will fit will be none. Now, then what can we do with the remaining 0.4 minutes? Actually, we can do nothing with it. This will be the idle time for workstation 1. the idle time, which means that this is time it will be wasted. Similarly, we can work on workstation 2 and 3 and assign the job following the steps we just demonstrated. And eventually, we assigned the jobs to these 3 workstations. So workstation 1 only work on A and C. Workstation 2 work on B, D, and E. Workstation 3 will work on F, G, H. Next, we want to compute the resulting percent idle time and the efficiency of the system. So the total idle time can be calculated from the previous assignment table, because for each workstation we already calculated the idle time for it. There are 3 of them. Workstation 1 has an idle time of 0.4 minutes. Workstation 2 has an idle time of 0.3 minutes. And the workstation 3 has idle time of 0.9 minutes. We add them up, get an idle time of 1.6 minutes. The total workstation time, each of them has 2 minutes, so we have a total workstation time equals to 6 minutes. The percentage of idle time is what we call the balance delay. It's defined as total idle time divided by total workstation time. So we divide 1.6 by 6, give us 26.67%. This is the percent idle time, and it is also the balance delay. Efficiency is 100% minus this balance delay, which is the percentage of time that we are really working on the assigned jobs. The balance delay, or the percentage of idle time, is the percentage of time that we do not work on the given tasks. So this is how we calculate the efficiency through the balance delay. However, sometimes we can calculate the efficiency in a more direct way. Now here, I calculate the efficiency by using 4.4 divided by 6. It gave us the same number, 73.33%. So why can I use this? Because the total workstation time is 6 minutes, as we showed earlier. However, the total task processing time is 4.4 minutes, which means among the 6 minutes, there will be 4.4 minutes be used to finish all the tasks. So the percentage of time that we are using or we are working on the assigned tasks is the efficiency. And this is another way to calculate the system efficiency.